Our final target of the unit was talking about the difference between an element, compound, and mixture. All of these are types of matter that we have in the world, and they have some differences that we need to know about. The first one that we looked at was a compound. Now we know elements are atoms that are exactly the same, which means they have the same number of protons in their nucleus. Compounds are made up of elements. In fact, they're made up of two or more different elements that are chemically combined. And when we mean chemically combined, we're talking about being bonded together. Oftentimes, those valence electrons are what helps create that bond between elements. Now, the compounds can be broken into simpler substances. They cannot be separated physically, and the compounds have different properties than what made them up. This particular bullet point right here is extremely important to understand that I may have two different elements that have different properties, but when I combine them, that new molecule is going to have different properties from either of the elements that made it up. So, for example, I have sodium here. Sodium atoms are highly reactive. You can see they have a shiny metallic luster to them. They'll conduct electricity. These are highly reactive atoms because they're trying desperately to get rid of their one valence electron so they can have full outer energy levels or electron shells. If you were to ingest this, it would not be a healthy thing to do because this type of metal is highly reactive with water and oxygen. So your body is filled with a lot of water, and so it would begin to react with unhealthy consequences for you. In fact, I have seen this before begin to spark on top of water. Chlorine gas is a very toxic green gas, and it's a highly reactive nonmetal. It's part of the halogen family. If you ingested this, it would also not be good for your health. Both of these things have chemical properties that are very dangerous to us. But when they bond together, they'll create a white crystal non reactive compound known as table salt, which we end up putting on our food on a daily basis. So this does not have properties of chlorine or sodium. A compound will get brand new properties that are different from the substances that make it up. I can look at these slides right here and determine that these are images of a compound because I have more than one element combined. Here I have one carbon atom combined with four hydrogen. Here I have a sodium combined with chlorine. It doesn't matter how many you have. For example, this one has four hydrogens combined to one carbon, where this just has two atoms combined together. It doesn't matter how many atoms you have bound together. What matters is the fact that I see two different elements that are bonded together. That's what creates a compound. Oftentimes, that compound gets its own chemical formula or chemical symbol. Here I have a compound or a molecule that is made up of three different elements: carbon, hydrogen, and oxygen. And I can see how many atoms make up each molecule. So this particular molecule has 6 carbon, 12 hydrogen, and 6 oxygen. So it's actually a very large molecule because it has a total of 24 atoms that make up one molecule of glucose, which is what this formula is for. And I can look at that symbol and I can tell that there's two different elements that make up water, or I could look at a visual representation that shows that I have two different atoms that make up water. Here I can see I have two different elements or atoms that make up methane. Now, mixtures, on the other hand, are different. Mixtures are a combination of two or more substances that are not chemically combined, and they can be separated physically. And each substance within it keeps its original properties. So, for example, I have trail mix here. If I were to pick out one of those almonds and taste it, it would taste like an almond. Just because I mixed it with these raisins and the granola, it doesn't give it a different taste. It doesn't take on different properties than what it had originally. And I can separate out all the things that I like from this particular mix, and I can eat the things that I like, and I can throw the stuff away or give the healthy stuff to my kids because I'm able to separate it. If I look at more images, if this is Skittles and M&Ms that are mixed together, then I could pick out all of the red M&Ms and the green Skittles and the yellow Skittles and the purple Skittles, and I could separate it out into the substances that I was looking for. So if the matter is a pure substance, which means all of the atoms or molecules are exactly alike, then that means it is a compound. If I can't separate out all the mixtures because they're not chemically combined, then that means I'm looking at a mixture. So when we looked at some of these in class, we said this fruit salad is a mixture because I can pick this strawberry out, and that strawberry is still going to taste like a strawberry. It's going to have the properties of a strawberry, and this grape is going to have the properties of a grape. This blue atom is still going to have the properties of whatever element it represents. These two red atoms are going to have the properties of whatever element it represents, because these two are not chemically bonded together. So all the molecules in this substance are not exactly alike. Here, the molecules in this particular substance are all alike, but they have two different atoms that are bonded together. So this is considered a pure substance because all of the molecules are the same, but it's considered a compound because I have two different elements bonded together to make that particular substance. Here, once again, two different elements bonded together to make this molecule. That means that this is a compound. And I know it's a true compound because every molecule in this substance was the same. Those same two elements bonded together. This was a mixture. I have a compound here of a molecule. I have a compound here, but down here, this particular atom was by itself. It didn't look like the rest of the molecules. So I have a compound, but this compound is mixed with other matter. So it's considered a mixture. This would have properties, and this would have properties, and it would keep its own properties because they were not chemically combined with each other. And we did a snap cube activity where we made some of those molecules and we looked at the difference between an element, compound, and mixture. In this page, all of these are elements. This is an oxygen, hydrogen, carbon. Even though there's two molecules here, it is still an element because both atoms are the same. Here is an element, both atoms are the same. Here is an element, both atoms in this molecule are the same. Here is an element because both atoms in this molecule are the same. But this is a compound. I have two atoms bonded together and they are different from each other. So I have a compound here of carbon and oxygen, a compound of hydrogen and oxygen, a compound of hydrogen and nitrogen, and a very large molecule known as glucose with carbon, hydrogen, and oxygen. So all of these are molecules, one molecule, that have at least two elements bonded to, or different elements bonded together. So all of these put with other molecules that look like it would make a compound. This is examples of a mixture though. I have an element here of oxygen. Here I have an elemental molecule here of nitrogen. These two are not bonded together. So it is a mixture of oxygen and nitrogen. Here is a sodium and chlorine atom bonded together. Here is a water molecule with hydrogen and oxygen is bonded together. But these two molecules are not bonded together with each other, which means they are simply mixed together. So when I mix water and salt together, that is actually a mixture. I can boil the water off and get left with the salt behind, so I can still separate it out physically. Here is a molecule and another molecule. Notice that each are made up of two or more elements, but these are not bonded together, so they are thrown or mixed together. And finally, this represents an oxygen molecule, a nitrogen molecule, a water molecule, and a carbon dioxide molecule. So you can actually have multiple molecules thrown together. As long as there's no bonding between any of them and they're just kind of mixed together, then that is considered a mixture. It doesn't matter if you're creating a compound or a mixture, though. We know that when you change the matter into a compound or into a mixture, that matter cannot be created or destroyed. The only thing you can do is change its form, which means I can change it into a mixture or I can change it into a compound. If I looked at my Mastery Connect, I can pinpoint that X is an element, all of them are the same. Y is a compound, all of the molecules are the same, but they're made of two different elements. Once again, Z was a compound, all of the molecules are the same, and they're made of at least two different elements. This one is a mixture though. I have several different atoms and molecules just mixed together.